Now let's look at the very last problem. Here we want to look at the area of the region bounded by these two curves. One is the cardioid r equals 1 plus cosine theta. The other one is the circle r equals 1. Again, the r equals 1 is fairly easy. That's just a unit circle, center at the origin. But I would like you to invite you to graph this by hand. One is the reasons are this. When you create it by hand, you know when angle, like exactly which piece of the graph corresponds to what angle. This is crucial when you find the area, because you have to decide the angles, right, for the corresponding piece. So this is important. Now, so you should pause the video here, try to sketch the graph of this cardioid. For convenience purpose, I have created that in Mathematica. So we are looking at the region bounded by these two graphs, basically this shaded area. And this shaded area can actually divide it into several pieces. One is, this is just half of circle, right? So it's easy to find this area, which is half of the circle, which is half of pi r squared. This is a unit circle, so half of pi for this shaded area. And so we just need to find this piece and this piece. But these two pieces are the same, so we just need to find one piece. Now, for this piece, you can, when you create the graph of this cardioid, you can confirm that to create this piece, again, just like the what I would ask you in calculus when you find the area, I will also ask you the same. So create a slice, just draw a one line, so that you know it hits which function, right? So here, this angle for this piece, at this point the angle is pi over 2 when you create this graph, and at this point the graph is pi, so it goes from pi over 2 to pi. So with that, let me actually copy this graph to here, just for convenience purpose. Okay, so to find this area, I'm gonna set up my integral using the angle from 0 to pi over 2 to pi, and this is for this slice. Now again, when we draw one little slice, we can see that it's hitting this function. So 1/2 1 plus cosine theta squared d theta. And this is just that slice. It's not the whole region included, bounded by these two graphs. Now let's do some algebra here. Pi over 2 to pi, this is 1 plus 2 cosine theta plus cosine theta squared d theta. Okay, and let's find this. The antiderivative of these two is straightforward, but for the very last piece, we need to use the half angle formula again. So let's do that before we integrate these two. So it will be half of 1 plus, okay, now double this angle, which is 2 theta in this case, d theta, and pi and pi over 2 here. There's a 1 here. This is the 1/2. So combined, we have 3 halves. This is 2 cosine theta, and we are left with the very last piece, half of cosine 2 theta d theta. Now we can do the antiderivative. So 1/2 of pi here, pi over 2 here. Oops, I'm actually doing the antiderivative, so I no more the integral symbol. 3/2 of theta plus 2 sine theta plus 1/4 of cosine sine 2 theta. And the angles go from pi over 2 to pi. Alright, and then plug in these two values, and then when you plug in pi, this will be gone, this will be gone, right? So when you plug in pi, those will be 0. So we are left with 3/2 pi. When you plug in pi over 2, the first term is 3/2 pi over 2. The next one will be 2. So with the negative subtraction, it's minus 2. We'll plug in pi over 2 in the last piece. It becomes sine pi, which is 0. So therefore, this is it. And let's simplify. And after simplification, it becomes 3 pi over 4 minus 1. So this is just that piece. Now, as the final answer for this guy, the area, so the area is equal to twice of this piece, right? 3 pi over 4 minus 1. And then plus half of the circle, which is pi over 2. Okay? And then, which is equal to, so do the simplification, this is 3 pi over 2 minus 2 plus pi over 2, which becomes, we have 2 pi minus 2 at the end. Okay, so this is it.